Hi you guys, today we're going to be doing projectile motion for our set of notes. Your essential question for today, what are all of the characteristics projectile motion helps us determine? So some of the things that you guys need to remember here. So first thing, how do I identify the axis of symmetry when in standard form? So when you're in standard form, make sure you guys write this down. I'm not going to write it down in the notes, but make sure you guys do. In the guided notes there, so negative b over 2a is how you identify the axis of symmetry when you're in standard form. So we're going to be using that formula to help us out in there. And then the next thing, how to identify the vertex when in standard form. So you need to take that value that you just got from the formula you used to identify the axis of symmetry and plug that back into the original equation for x, or whatever x variable, like it might be t in time. You're basically plugging it back into the original equation and solving for y. Also, think of like as hk, h comma k, as your point, where h is x, the x value of the vertex, and k is the y value of the vertex. If you guys remember these two things, so just basically how to find your vertex in standard form as well as your axis of symmetry using that formula negative b over 2a, then you guys will be 100% ready to get this done. Okay, so let's go through and actually do two examples that we're going to do today. So your first example is actually written for you guys. A soccer ball is kicked from the ground with an initial velocity of 90 feet per second. The equation h equals negative 16t squared plus 90t gives the height h of the ball after t seconds. So the t in this case is actually our x that I was kind of talking about and referencing, and the h is our y. So these kind of represent our x's and y's. So this time they're just representing our t in time and then h as height. So what we want to try and determine the seconds it takes for the ball to reach its maximum height here. So in order for it to reach the maximum height, we need to, so if we're kicking a ball down here and we're kicking it, it's going to go up and then back down. So the maximum height is going to be what? Yep, you guessed it, the vertex. But when we have our vertex, we have h comma k. So if you kind of think of it, we're talking about on a graph. So which axis would represent height and which one would represent time? Well, time is always the independent variable here, and then your dependent variable would be the height, because depending on which time happens, our graph would be here because we're kicking the ball, and then it'd be going up like this, then hit back down on the ground. So your time is going to be the x value, so that's actually, it's kind of confusing because h is actually the variable for that, but t would be represented in time, and then our k would be the y value. So remember x and y, this is our x-axis, and then this would be our y-axis. Okay, so what we're going to do is we actually are going to have to try and figure out, it wants us to determine the seconds. So x, that's our time. So x, remember here, this is representing our time. So we need to figure out that x value of our vertex, that point. So guess what? That's our axis of symmetry equation, the negative b over 2a. So what we're going to do, luckily we already are in standard form. We're going to identify the a, which is a negative 16, and then our b value, which is a 90. Okay, so now we're going to go ahead and plug my c term. I don't actually have one. If you had a c term, it would be 0. Now I'm going to actually go ahead and plug that in for my equation. So I have a negative and then b value of 90. And then we're going to divide that by 2 times negative 16. And then we're going to have our 2 times negative 16, which we have our negative 32. We're going to go ahead and simplify that fraction. I'm going to go ahead and get a decimal, but I do know that a negative divided by a negative is going to be a positive, and then when I get 90 divided by 32, we actually get 2.81, and then we have to make sure what we are measuring in. We are in seconds, so our final answer would be 281 seconds, or 2.81 seconds. So, in our last part, or like in part 3, we're going to actually be writing these in sentences, so we'll come back to this one in a second. But for now, the seconds that the ball reaches its max height was at 2.81 seconds, which was right here. So now let's continue with this same example here. It's still the same one, but this time we're going to find the maximum height of the ball. So using that formula that we went and, or that value that we got, we're going to plug it into the letter T, or X, like you guys, like I said in the notes. We're going to plug that in and actually determine our height. So we have a negative 16, and we got the 2, let me go back, 2.81. So 2.81 squared plus 90 times 2.81. So now I'm going to go ahead and do 2.81 squared first, and then we're going to multiply that by our 16. So let me get this out of the way. So now we have h equals 2.81 squared, and then times negative 16. We get a negative 126.34. Then our next thing that we're going to multiply is the 90 times 2.81, and for that we get 252.9. I'm just entering this on my calculator, you guys. I'm not coming up with this out of my head, so just to give you a heads up. And then we're going to go ahead and go through and now add those. So let me just double check this really fast. Yes, so when we go ahead and add those, we actually have more positives than we have negatives. So when I have 252.9 minus 126.34, you get 126.56. And we were measuring our height in feet there. So we're going to go ahead and write feet as our units. So the ball's maximum height was at 126.56 feet. Okay, so now we're going to actually, now part C, what do the solutions for part A and B mean in context to the problem? We're going to write sentences, or a sentence or two for each of those answers. So this is what I want you guys writing as your complete sentences. You'll see it on the worksheets and the examples that you're going to be doing on your own. So for this sentence, we're going to say at 2.81 seconds, the ball reached its max height of, and we had our max height was 100, max height, oh that's right, of real fast, of 126.56 feet. Okay, so that's okay to do my one sentence like that. You guys can write them in separate sentences. You could just say the ball took 2.81 seconds to reach its max height, and then the ball's max height was 126.56 feet. Okay, so let's do one more example just so you guys can get the hang of it. So an apple is launched directly upward and at 64 feet per second from a platform 80 feet high. So all of a sudden, see how in this last equation we didn't have a C term because we were actually on the ground level. So now we are at a platform that's 80 feet tall. So we raised our platform. We aren't at 0, 0. We're not on the ground anymore. We actually are kicking it from the platform, so we were up 80 feet. The equation for this apple's height, h, at time t seconds after launch is that h equals negative 16t squared plus 64t plus 80. You're going to find the seconds it takes for the apple to reach its maximum height. So when we go ahead, we're going to do the maximum height again, and then we're talking about seconds, which is our t in time, so that's our x value of our vertex. We're going to be using that negative b over 2a formula again. So I'm going to go ahead and I'm going to make sure that I identify my a and b first. So a equals negative 16 here. My b value happens to be 64. So now when I go ahead and plug in 64 for b, and then I have 2 times negative 16, which is my a value. So now I have negative 64 divided by a negative 32. And then that happens to be just half of that. So negative by a negative is a positive, and then 32 goes into 64 twice, and we were in our units of seconds. Okay, so that's our final answer for that one. The apple, to reach its max height, only took 2 seconds. Part B of that same example, you're going to find the maximum height of the ball. So again, we're going to plug in that 2 seconds into our original formula here. So if I have h equals negative 16 2 squared plus 64 times 2 plus 80. Now we're going to go through and head and solve for our y value of our vertex. So you're just basically finding the vertex if they're asking for max heights, you guys. So now 2 squared is 4. 4 times negative 16, we get negative 64. Plus 64 times 2 is 128 plus 80. So h equals, now we're going to do 128 plus 80 minus 64. We get 144 feet. So our apple reached its max height at 144 feet. So these sentences that I'm saying to you guys as well are also the concluding sentences that you guys will be writing at our final part of our question. So the last part of this one, the second to last part, determine the seconds it took for the apple to reach the ground. So we need to figure out, so far we figured out the max. We did the x value and the y value of the vertex. Now we need to figure out when it actually reaches the ground, and it's going to be a little bit down here because remember we are on a platform of 80 feet here. Okay, so now I'm going to be reaching the ground. So what is our height when we are at the ground? When we've reached the ground, we no longer actually have a height of 80. We are at 0. And remember, your h represents the height, so we're going to plug in 0 for the h, and we're going to go ahead and actually have to factor this to figure out what our 0 values are. So we're going to rewrite this equation, but we're having a 0 in for h instead. And then now I'm going to go ahead and actually take out a GCF of negative 16. I'm going to take out negative because I don't want my t squared value to be negative. 64 divided by negative 16 is a negative 4. Bring that t value there. And then 80 divided by negative 16 is a negative 5. Now this looks a little bit easier to factor. So my factors, you're trying to figure out what multiplies to negative 5 but adds to your negative 4. So we're going to go, don't forget your GCF out in front there. So I have a t, and now remember we have a coefficient of 1 right here. So I just get to write my parentheses. So I have a t minus 5. We want that definitely to be a minus 5, and then t plus 1. So we're now going to set these equal to 0 here. Okay, this is where we're identifying our zeros of our parabola. So now I have a negative 16, which actually can't equal 0. We get to eliminate that one. T minus 5 equals 0. In order to solve for that, I add 5, so I get t equals 5 here. Now I have t plus 1 and equals 0. I'm going to subtract 1 from both sides, and I get t equals negative 1. So let's think about this. We either have it takes time, it either takes 5 seconds or it takes negative 1 seconds. So what actually makes sense here? Well, we can't have negative time, so you don't get to include the negative distance or the negative time. So t equaling 5 seconds actually has to be our conclusion there. Okay, so we can't have negative time. We also can't have negative $16 ever equal $0. So our only solution that makes sense is that positive value. So let's go ahead and finish this by actually writing down what our solutions mean in context. So from parts A, B, and C. So for that part A, we were talking about the time in seconds and our max height. So I'm going to use kind of a similar sentence like our first example. So at 2 seconds, the apple reached its max height, max height of 144 feet. Okay, so that's our one sentence that we could put the A and B together, so we accomplished with those. But that part C is actually a little bit different. So how long did it actually take to hit the ground? Well, it took 5 seconds to reach the ground, which is our height of 0, right? So it took 5 seconds to reach the ground. And you can even say if it took 5 seconds for the apple to reach the ground, whatever you guys think makes more sense, but it took 5 seconds overall to reach the ground. Alright, so just to give you guys a heads up, so you're basically just using your axis of symmetry formula, that negative b over 2a, and then you're plugging that back into the original equation to identify the vertex. The other part you're doing was plugging in 0 for our y value to determine whether that equation will actually hit the ground. So hope you guys understand that. Please return or rewind, pause, whatever you need to actually go back over these, make it make sense, and I will talk to you guys soon. Thanks.